Hi all, in this session we are going to actually talk about Matplotlib. So this is from Matlab, so that's why it is Matplotlib. So by the name itself it is very understandable for you. It is a library which is actually for plotting. Okay, so it is a library which actually supports a lot of plotting the data or visualization of the data. And this is the Python's primary library for 2D plotting and visualization. And if you want to see a lot of interactive visualizations like animated one and static one, anything you can actually develop by using this Matplotlib. And line charts, bar charts, heat maps, and all those things are very closely you could see, and you can integrate well with the NumPy and the pandas for all the visualizations of your numerical and tabular data. And the main goal itself is to make easy way to make the plots and the graphs and for data analysis and presentation. And now moving back to its why we go for the Matplotlib is that its versatility, because wide range of plots, whatever you want, you imagine about it, okay, you have a plot for it. So customization, you can actually try different legends, labels, color charts, and all those titles, and everything is actually possible for you. And you can integrate it easily with an NumPy and pandas and scikit-learn, etc., sklearn, or whatever it is. You can actually combine it and integrate it with various other packages which is given by the Python, and you can easily use this for the visualization purposes. So this is kind of the anatomy in the sense, like how it will look like a plot. So for that, the first one which you have to keep in mind is that you have a figure. So one figure will be there, right? And in the figure you will have axes. So axes is like your subplots, and then comes the main axis, x-axis, the y-axis, and all those information. Then the data points, the charts, and everything will be there. And you will have labels and titles. So the title will describe your data, and X label and Y label will describe the x-axis and the y-axis accordingly. And then there will be legend, which will actually gives you which color is actually used for what purposes. So it's kind of a legend which actually gives you more details about it. So when you look at it, you will have matplotlib.pyplot as plt. So matplotlib.pyplot is the the package and the function which is used, and they are actually renamed as plt. So whenever we are going to use matplotlib.pyplot, we will be calling it as plt. And so plt.figure, so you will have a figure, then you will have axes, so that's why it is actually given one set of axes. They are like the subplots. And then so we are just using it as ax, right? So ax dot set title, you can set a title, you can set the x label, y label, then you can actually plot it as a line, and you're giving the label as line 1, and you're giving a legend also. So let's try this right away and see how does it actually work. And this is the first one. So when you try this, you could understand that this is your figure. So it is actually given here what is the figure size, right? So a figure is there, and then you have this figure and axis, right? Figure and axis. So this is your subplot. So you have x-axis and the y-axis. So one set of axis is there for your figure, and in the ax dot set title my plot. So you have actually given a plot as my plot as the title, and there is an x label, and in the x label I want it to be written as x-axis label, and in the y label I want to write it as y-axis label. So when you look at it, x-axis label, y-axis label. So I have given the names. Then what is to be plotted? I want to be plotted it as a line 1. So this line is actually the line 1. Okay, I want it to be called as line 1. And what am I trying to print? I am trying to print 1 2 3 4 5 6. Okay, 1 2 3 4 5 6. I also have this legend. So this legend is nothing but which is actually giving this line 1. So legend actually gives me that, okay, this line which goes through it is nothing but the line 1. Okay, so all this information, this is nothing but the anatomy. So this is how a particular plot will look like. So any plot if you take, this structure will be there. Some figure will be there, the axes with the set of axes will be there, then x-axis or y-axis and its corresponding labels, the data points itself, then the labels and the titles and the legend. So this is how the plots will look like. Then comes to the first chart, in fact, so line chart. So when are we going to use the line chart? So line chart is actually nothing but a display of a connection of display points by straight lines. And what are we actually using that? We will normally use it for the trends, the changes over time, the relationship between the variables, etc. So here, for the sake of example, we are actually taking matplotlib.pyplot as plt and numpy also, because we want some random numbers to be plotted. So we are taking the numbers from 0 and 10. It is exclusive of it, and we need the steps to be 100, and we are applying the sign value onto the x, and x and y label is actually given as sin x, the line plot for the x, and plt x label is x and y label is sin x, and we have a legend, and I want the grid lines, we want this background grid lines to be true, and plt.show. Plt.show is the easiest way for actually showing or displaying your the figure. So when you look at it, you could see that it is actually given the line plot of x. The line plot of x is the title, and if you see, this is x and this is sin x, and it has actually taken the values between 0 and 10. Okay, so 0 and 10, the 0 to 1, those values are actually taken, and so -1 to +1 is actually taken, right? So this is how the line plot will look like. So if you want to change here, okay, so linspace, I am just changing it as 9, and you can run it. So what is the change that you could see? So here the changes is actually seen. So I'm just changing it as 10 again, and I'm just running it. So you could change the values, changed as 10. And if you want to change, so like that, try to work with say 50. So if I'm trying to change with 50, so you could see that the changes are there, but no major changes are actually seen. So maybe I'll give something like 5. So let us see. So you could see that the values are also getting changed, right? So 0, and so when you look at it, so here now I'm going to give it as 100 itself. So if I give 100 and I'm just going to run this, so you could see that the values are actually changed. Basically, accordingly, the values are basically changed. Now the next one is basically the bar chart. So when you look at it, this is the bar chart. So when you look at, you have actually categorical values, and you are actually the values are actually given like this. So this is your and you are actually plotting the categories, the values. So x label is fruit and y label is quantity, and you are actually talking about the quantity of each and every one. So the apples are actually 10, and this is actually 15, and this is actually 7, like that you are plotting the graph. And then comes the scatter chart. Scatter chart or the scatter plot is very important, because it actually gives you a very good understanding between the relationship between the x and the y values. So you're taking two random seeds, that is 50 and 50. Both of them are 50. In fact, here in the x-axis and the y-axis, you will have all the values between 50, and when you look at it, you are marking it as red, and the scatter, right? So it actually shows you the relationship, the correlation between the values, the clusters, the outliers, etc. And histogram is also very important for the visualization of distribution of the data. And if you could see that, say if you see a distribution like this, almost like a normal distribution, so you could see that where the mean of the topic lies, and etc. Right? So this is histogram. So histogram always comes with the data, and the histogram needs bins. You will understand it a little bit later, but just understand that it is bin, and then the color is green and alpha, etc. Right? All this information is actually given, and you will get the histogram. Then the numpy with path. So we already told that we can integrate matplotlib with both numpy and the pandas. So numpy generates large numeric data sets, and matplotlib will be able to help and visualize them in the. So here we are actually again generating a random this thing, and we are trying to identify how it works. And pandas can also be associated with it, because this is a very wide commonly used one. So when you look at it, you have a data frame, and you are actually randomly generating two different A and B data, and you are trying to plot it the cumulative one. So this is something which look like, so every time, but when you do it it is the seed is actually given, it will be almost the similar one. So that's all about it. So let's go back to our this one. So this is our bar chart. When you look at the bar chart, you have your apples, etc., and you are actually trying to fulfill it. Okay, then the scatter plot, again we have actually taken two different random values. So every time when you run it, you will get the almost get the the same plot itself. All right, so this is what it is. So you are randomly taking 50 values, and then you are trying to identify that. Okay, so this is something which you have to know. Then histogram, in histogram you have data, and each of your data has to be put into certain bins, and then you need to do it. So this is exactly what it is, and so it actually helps us to understand and identify the normal distribution. And then comes the numpy with matplotlib. So you are actually generating some random data points with the help of the numpy, and that y-axis is actually the sin x, and x-axis is those values which are actually generated, and we are trying to plot it, so it gives you a smooth curve. And then comes yeah, this is small explanation which is actually given over here. If you want, actually you can have a look. And yeah, plt dot grid of true is nothing but the background grid of the image will be actually shown. And then here we are just taking a random cumulative sum of two different things, and we are trying to find out the cumulative sum of the random data also. So this is how actually it will look like. So that's all from our side. So just understand one thing, this matplotlib is basically used for all the visualization and visualization purposes, and it actually works well with both pandas and numpy. And this would be really helpful for you for better analysis of your data, for finding the correlation between the data, for which one would be the right um, uh, right visualization that could be used for your data. All those things can be used when understood with the help of the matplotlib. So hope you get some idea about the visualizations as well. So please go home and give a good try about all this, and tweak a little bit and try and make sure that you understand. If you have any doubts, you can always get back to me. Thank you so much.